Okay, so now we'll discuss the Millman's theorem. First, a brief introduction. The Millman's theorem was named after the famous electrical engineering professor Jacob Millman, who proposed the idea of this theorem. Millman's theorem acts as a very strong tool in case of simplifying the special type of complex electrical circuit. This theorem is nothing but a combination of Thevenin's theorem and Norton's theorem. It is very useful theorem to find out voltage across the load and current through the load. This theorem is also called a parallel generator theorem. Millman's theorem is applicable to a circuit which may contain only voltage source in parallel or a mixture of voltage and current sources connected in parallel. Now the statement for Millman's theorem. The Millman's theorem states that when a number of voltage sources, say V1, V2, V3 till Vn, are in parallel having internal resistance R1, R2, R3, Rn respectively, the arrangement can be replaced by a single equivalent voltage source V in series with a equivalent series resistance R. Now what is the utility of this Millman's theorem? The utility of Millman's theorem is that the number of parallel voltage sources can be reduced to one equivalent source. It is applicable only to solve the parallel branch with one resistance connected to one voltage source or current source. It is also used in solving network having an unbalanced bridge circuit. Now here we are having parallel voltage sources resistance which can be reduced to a single source. Okay, now we'll explain it. Let us have a circuit as shown in figure A. Now this is the circuit V1, R1, V2, R2, V3, R3, and this is RL, and this is the voltage drop across RL. So these are all connected in parallel. Now here V1, V2 and V3 are voltages of respectively first, second and third branch, and R1, R2, R3 are respectively their resistances. Now IL, that is the load current, RL and Vt are the load current, load resistance and load voltages respectively. Okay, now this complex circuit can be reduced easily to a single equivalent voltage source with a series resistance with the help of Millman's theorem as shown in figure B. This will come out to be RTH, V, this is RL, IL, and this will be the Vt. Now what will be your V? V will be V1 plus R1, V1 by R1 plus V2 by R2 plus V3 by R3 by 1 by R1 plus 1 by R2 plus 1 by R3. It is summation of V by R and summation of 1 by R. Now this VE is nothing but the Thevenin's voltage and Thevenin's resistance RTH can be determined as per the convention by shorting the voltage sources. So RTH will be obtained as this has already been discussed, that RTH is 1 by R1 plus 1 by R2 plus 1 by R3, and the load current and terminal voltage can be easily found out by IL, that is VTH by RL plus RTH, and VTH is equal to IL into RL. Now let us take one example. A circuit is given as shown here in figure C. We have to find out the voltage across the 2 ohm resistance and current through the 2 ohm resistance. So this is our circuit where there are current sources and resistances connected in parallel. Okay, now we go through any solving method to solve this problem, but the most effective and time saving method will be none other than Millman's theorem. Given circuit can be reduced to a circuit shown in figure D where equivalent voltage VE can be obtained by Millman's theorem, and that is how I am showing you. This is your VE, there is RTH. Now VE is what? See, this was the current source, so V will be 50 by 5 minus 20 by 20 plus 16 by 4, and the resistance will be 1 by 5 plus 1 by 20 plus 1 by 4 is equal to 26 volt. Now RTH is again the Thevenin's equivalent resistance which can be found out using this. RTH will be this, which is 2 ohm. Now we can easily found the required current through 2 ohm. The I2 ohm is equal to 26 by 2 plus 2, that is 6.5 ampere, and the voltage required is I2 ohm into 2, that is 6.5 into 2, that is 13 volt. So it's very easy to do it using Millman's theorem. Now we'll discuss another example. A circuit is given as shown here, and the resistance is, we have to find out the current through the resistance RL equal to 8 ohm. This problem we will again do with using Millman's theorem. And see, this is the reduced circuit diagram where V is 10 plus 0 by 24, 24 by 8 minus 48 by 12. This is very easy because we are just using the sign convention. We are getting this by this, so it's 36 volt and RTH is 6 ohm. Therefore, the current through the load resistance 8 ohm will be 36 by 6 plus 8, that is 2.57 amperes. Thank you.